Example 2. Find the surface area of the following. We can see that this is a rectangular prism because we have two faces that are opposite each other that are rectangles, and all the other faces are also rectangles. So it's a prism because the other faces are rectangles, and it's a rectangular prism because we have a rectangle right here. I know the way that I drew it kind of looks like square here, but this is 3 centimeters and this is 5 centimeters. So those are different, so it's a rectangle. So it's nice to start off by listing the different measurements that we know. I know that the length here is 3 centimeters. The width is 2 centimeters. And the height is 5 centimeters. I could have labeled it differently. I could have called this the length and this the width. It really doesn't matter in the end. But that's just the way that I'm doing it now. Length, width, and height. The formula that you were given for finding the surface area is that surface area is equal to 2 times the length times height plus 2 times the width times the height plus 2 times the width times the length. So that's our formula. When there's no sign in front of the variables, that means we are multiplying. So what surface area is, it is saying, okay, well, we have a rectangular prism right here, this Kleenex box. I know that it's a rectangular prism because on this side I have a rectangle, and on all the other sides are also rectangles. If I'm talking about volume, I'm going to ask myself how much can fit inside the box. Surface area, on the other hand, isn't talking about how much can fit inside, it's talking about the outside of the shape. So if I were to unfold it, I want to be able to calculate the area of each of these rectangles and add it together. That's what surface area is. All of the surfaces of my shape, if I find the area of all of the surfaces and add it together, or you can think of it like the shape unfolded, that would be finding surface area. So I'm concerned about the outside of the shape, what the area is on all of the sides on the outside of the shape. I know that my length is 3. My height is 5. 2 times my width is 2. My height is 5. Plus 2 times my width is 2. And 2 times 3. Okay, so this L looked like an H, so it confused me, but you should never have the same thing multiplied twice unless some of the sides are the same. So this is what it should look like. So 2 times 3 times 5, 2 times 3 is 6, times 5 is 30, plus, so I'm doing BEDMAS, I'm doing the multiplication first. 2 times 2 is 4, times 5 is 20, plus 2 times 2 is 4, times 3 is 12. And then I can add it all together. 3 plus 20 is 50, plus 12 is 62. And my unit, centimeters squared. So that means that if I take all of the surfaces on this rectangular prism, on this box, and I add it all together, the area of each of the individual surfaces, I would, for this box, I would get 62 centimeters. And just to give you a bit of a visual of what that looks like, here I have 2 times length times height. That means length and height are this side and this side, and they make this rectangle right here. So that's the area that I'm finding first, and I'm multiplying it by 2 because this face is opposite this face and they're the same. Next, I have 2 times width times height. So width times height is this rectangle right here. And I also see it on the opposite side here, width times height. The third one, 2 times width times length. So width times length is right here. So it's this rectangle right here at the bottom, which is the same as width times length, this rectangle here at the top. So that's why we're multiplying it by 2, because every face has a pair that's identical. Excuse me. So that's why we have to double each of those measurements. Alternatively, you could have written out the formula like this. You could also first multiply each of the faces and then double it. You can also write the formula like that. Both ways work.